Hey everybody, welcome to another video lesson. In this lesson, we're going to talk about something that we call complex numbers. You might be wondering what the heck that means. What does it mean for a number to be complex? That's what we're going to dive into for this video. Remember, in this unit, we've been talking about solving quadratic equations. That's still the focus. Complex numbers are going to have a part to play in that. We need to take a moment to think about these things and talk about them before we can continue solving quadratics. So let me just show you what a complex number is. All right, so imagine with me that I gave you this equation, and I told you to solve it by taking square roots, just like we did in that last video. Well, what you would do is say, I want to get the thing being squared alone. So you would subtract 24. So you could get 3x squared equals negative 24. You divide by 3 to get x squared all by itself. And then you would be left with x squared equals negative 8. At this point, we said to solve, you take a square root of both sides. You have x equals plus or minus, don't forget the plus minus, the square root of negative 8. And the question becomes, what do you do with that negative sign in there? How do you have the square root of a negative number? What do we do with that? That's the question that we run into. How is it possible to have a square root of a negative number? Well, this is a problem that mathematicians ran into a long time ago. So essentially, we introduced this thing into the math world called complex numbers. Okay. Another word that we use for that is the imaginary number. So they call it I. It's the imaginary number I, and it just is the number whose square is negative 1, meaning I is the square root of negative 1. That's what that means. And if you think about it, the square root of negative 1, the way we think about numbers, it can't exist, right? It's either got to be 1 times 1 or 1 times negative, or negative 1 times negative 1. It can't be both, all right? So I is the imaginary number whose square root, it's the square root of negative 1. Okay, if that seems super crazy, if that seems super out there, just know that if I does not actually exist, like if we don't have I, then there are a lot of other things in math that kind of fall apart. So the imaginary number needs to be, it's really significant, and in fact, it's really imperative for the rest of math to really work. So the imaginary number must be a thing. We just call it an imaginary number because it's not a number like we think of it, right? It's not a positive number. It's not a negative number. It's something different. We'll also use the word complex number. Okay, but for now, just know this. I is the square root of negative 1. On the flip side, then, if you square I and you do I squared, that is negative 1. All right, so we're going to work with this a little bit. Let me show you where it might come up. Say I want to simplify these things like we did in the last video. I'm going to simplify some square roots. Well, if I look at this first one, what if I rewrote this as the square root of negative 1 times 2? Pulled our trick from last time and broke this up into 2 individual square roots. Well, then I have the square root of negative 1. And we said that I is the square root of negative 1, right? That's what it means. So this would become I times the square root of 2. What about another one? I rewrote negative 8 as, well, before I do that, let me just tell you how we're going to approach these. If at any point you see a negative sign inside of a square root, you can automatically say, just like in this problem, that an I is going to pop out in front of everything. Okay, so if I see this, it's the square root of negative 8. I see that negative sign, and I say, oh, I know that that's going to become I times the square root of 8. That negative sign inside the square just becomes an I out front immediately. And then I can break the rest of this thing down. So it's going to be I times the square root of, I can write it as 4 times 2. We're trying to use perfect square numbers. And break it down some more and split these things up. Square root of 4 times square root of 2. And the square root of 4, we know, is 2. So I have I times 2 times the square root of 2. Here's how we're going to write this. When you have I in a number, think of I as a variable. okay? Treat I like a variable. You wouldn't write x2, right? You'd write 2x. So the way we're going to write our final answer would be 2I times the square root of 2. That'd be our final. Okay. So these are the exact same process as they were in the previous video. The only difference is that when you got a negative sign inside of there, you know that it pops out to become an I in front of everything. Okay. Let's do another example, or a different type of problem I might come up when we're solving. You want to do this first example. We're trying to solve by taking a square root. Remember, we got to get the thing that's being squared all alone. So we would add 14 of negative 5x squared equals 26 plus 14 is 40. We divide by negative 5. And we get x squared equals negative 8. I take the square root of both sides, like we normally would. I have x equals plus or minus the square root of negative 8. Now we know how to break this thing up, right? In fact, we just did it. Right here, square root of negative 8 becomes 2I times the square root of 2. And so I know that this is going to become x equals plus or minus 2I times the square root of 2. And this will be our final answer there. So it's exactly the same process as it was in the previous video. We're just trying to get the thing being squared alone, take a square root to solve. Don't forget about the plus minus. But if we have a negative sign underneath that radical, now we know how to deal with it. Let's do another one. I want to solve this equation. I'll subtract 8. I'm trying to get the thing being squared alone. That's x plus 4. So I'm trying to get that one by itself. 2x plus 4 squared equals negative 42 minus 8 is negative 50. I'll have to divide by 2. X plus 4 squared equals, that's negative 25, negative 50 divided by 2. Now that this is all by itself, I can take a square root, just like before. X plus 4 equals plus or minus the square root of negative 25. Okay. Now, if we think about this, if we think about this, plus minus, I know the negative sign is going to pop out and give me an I. And the square root of 25, well, we know what that is, right? It's just 5. Okay. So you could look at it like this. You can have an I times the square root of 25. And you know that the square root of 25 is 5. So then you can just say 5I. Because remember, we treat I like a variable. So it always goes, square root of 25 becomes 5. And then we're going to write that first because we always write the I second. We're almost done here. I still need to subtract 4 to get x by itself. And here's a big rule for us, okay? If we're ever going to write something wacky like I'm going to have on the right side here, you got i's, you got plus or minus, you got a bunch of stuff going on. We always have the plus or minus in the middle, okay? Always have the plus or minus in the middle. So it's going to be negative 4 plus or minus I. That's my final solution. Okay. So I will come up when you're solving sometimes. Solve an equation using square roots just like we did normally. If you get a negative sign in your radical, you're going to have to get an imaginary number in there, but that is okay, right? That doesn't mean you've done anything wrong if you have a negative sign and a square root. It doesn't mean you did anything wrong if you have an I. We just need to work with those things. All right, a couple more things to this video. When we write complex numbers, remember that's just another word for imaginary numbers or numbers that involve an I. This is what we call the standard form of an imaginary number. Like I said, the plus or the minus will be in the middle, and the imaginary part, the part that includes the I, is always going to be written second, okay? When we say the real part, we mean it has no I. There's no imaginary part. Okay, so it goes real part, and then the imaginary part is second. We always write it like that. It's just good form for us. We'll always write the imaginary part second. Okay. So one more thing we got to do here. Sometimes we do operations with imaginary numbers. Okay, so I'm going to do a couple of these examples, and then that's going to be it for this video. Let's say I want to add and subtract some imaginary expressions. So I'm going to get A here. Well, I'm just going to, remember we said we treat I like a variable. And we're going to do the same exact thing here. Okay, so that means we can combine like terms with it, right? So in this first one, 5 plus 7i plus negative 2 plus 6i, I'm going to pay attention to what it's telling me to do. It's telling me to add. And then I'm just going to combine like terms. It's going to be 5 plus negative 2. Okay. Oops. 5 plus negative 2, that's 3. And then I'm going to have 7i plus 6i. 7 plus 6, remember, just pretend it's like 7x plus 6x. 7 plus 6, that's 13, plus 13i. And that's my final answer. Okay, what about if we subtract? Well, it's going to be really, really similar. I'm going to pay attention to what it's telling me to do. It's telling me to subtract. And now we're going to do like terms. So it's 8, right, a constant with no I attached to it, minus 2, another constant. 8 minus 2 is 6. And then I have 3i minus 4i. So 3 minus 4, that's negative 1. So I'm just going to have negative I, or negative 1i. That's my final answer. Okay, we'll look at one more before we move on to the last part. In this problem, it's 7 minus the whole quantity, 3 plus 2i. You can think about that like this. It's almost like you're distributing your negative sign, or you're subtracting each piece inside of here. Either way, it's going to look like this. 7 minus 3 minus 2i. Okay? You're subtracting each of these pieces. We're distributing the negative sign. And now again, we got some like terms. 7 minus 3. That can turn into 4 minus 2i. Okay. And now there's no other imaginary things to combine. The imaginary part is written second. So we're all done with that problem. Okay. All right, let's look at one more type of problem, and then we're going to wrap up this video. So that's adding and subtracting. Let's think about multiplying with imaginary numbers. So let's say I have 5i times negative 4i, where we still treat it like it's a variable. Okay, so this is like 5x times negative 4x. First we multiply the coefficients. So 5 times negative 4, that's negative 20. And then we multiply the i's. I times I is I squared. Just like x times x is x squared. We're just treating it like a variable. Okay. Now we got to remember, when I have an I squared, remember I is the square root of negative 1. That means that I squared is simply just negative 1. Okay, so anytime you see an I squared, throw off an alarm in your head to turn that thing into a negative 1. So it's going to look like this. Negative 20 times negative 1. I squared just becomes negative 1. And that is, of course, 1. And then we're done. So anytime you see an I squared, remember that's got to turn into a negative 1. All right, last example for us. Multiplying two binomials, we're going to double distribute this thing, which we've done a couple times in this class. I'm going to double distribute this. So one thing at a time. 2 times negative 3 is negative 6, and 2 times 5i. Again, just treat it like a variable. 2 times 5 is 10, and that has an I attached to it. Okay. Let's move on to the 3i. 3i times negative 3, that's minus 9i. And 3i times 5i, well, 3 times 5 is 15, and I times I, again, is I squared. So we got to see that I squared That should throw my brain off and say I need to turn that into a -1 before I do anything else. Anytime you got an I squared, turn it into a -1. So it's going to be -6 plus 10i minus 9i plus 15 times -1. So let's just simplify this a little bit. 10i and 9i, those are like terms, right? So we can combine those. And 15 times -1, well, that's the same thing as a -15, right? So we're going to have -6, 10i minus 9i is just 1i. So I have plus I minus 15. This is 15 times -1. Now I can combine some more like terms, -6 and -15. -6 minus 15 is a -21, and then I have that plus I at the end. There's nothing else for me to simplify. There's nothing else for me to combine. I'm in the correct format because I is written second, so that means I am all done. Would be 21 plus is my final answer. That's the big things to remember from this slide. When you have I squared, remember that turns into a -1 every time. Okay, if you have I squared, that turns into -1. And then otherwise, you're just treating I like it's a variable. Okay. The most important things for us is this variable. All right, so thank you guys for bearing with me. That's going to do it for this one. Let me know if you have any questions, and we will see you next time, okay?